Hello friends, I welcome you to video solutions of JEE Main 2019. First of all, I would congratulate NTA for performing this awesome job of maintaining uniformity across all 8 papers. They also conducted the paper on the legacy of JEE Main, where the 12th portion syllabus has been asked more as compared to the 11th syllabus portion. So today we will be starting with the very first paper, that is paper of 9 January morning session. Let's start with our question. Now as per the question, there is a ball of mass capital M which is suspended from the ceiling of the car with a light string of mass small m, and the light string's mass is very less than the mass of ball, right? Now when the car is at rest, the speed of transverse wave in string is 60 meter per second. That means at that time no pseudo force will be acting on it, and at that time the tension in the string would be simply mass of ball into g. When the car has acceleration a, the wave speed increases to 60.5 meter per second. That means the tension has certainly increased. Now there is an action of pseudo force as well, and we have to find the value of a in terms of gravitational acceleration g. So let's see the solution here. So let's suppose that this being the string, this is the ball of mass capital M in first case, and in the second case, when the car was accelerating with acceleration a with vertical, let's mark this as vertical. So with vertical, this ball is going to make a particular angle like this, with pseudo force acting on backward direction. This is acting downwards, right? Whereas here only this mg is acting with tension T, and here tension would be T dash. Now as per the formula, if you see that velocity of transverse wave is given by under root of tension by mu. This is mass per unit length of string, and here I'll say V dash would be equal to under root of T dash divided by mu. Same string would be there, so mu would be same. Taking the ratio of these, V dash by V would be simply equal to under root of T dash by T. Now when you talk about T dash, what would be the value of T dash? T dash equal to under root of capital M square A square plus capital M square G square, as by basic mechanical laws. And tension when the car was at rest would be simply equal to mg. Substituting these values, let's take this as equation 1, this as equation 2, and this as equation 3. When you put down all the values, you will get V dash by V is equals to under root of, so under root M square G square plus M square A square, and this whole should be divided by mg, right? On solving this, you will get V dash value would be 60.5. This value would be 60 as per the questions, and this would be under root of g square plus a square by g, right? On further solution, you will see that 60.5 divided by 60 would be simply equal to under root of 1 plus a by g whole square. I have taken g as a common, so this would be 60.5 divided by 60 power 4 would be equal to, calculating this I'll get a as 1.83, which is nearly equals to g by 5, right? Let's see which option is the best answer. So as per the options, I'll see that option 2 is the best answer. So answer to this question would be option 2. Hope you have understood this one. Let's take our next question. Now this question of parallel plate capacitor belongs to a segment of electromagnetism. As per the question, the parallel plate capacitor is made of two square plates of side A separated by distance small d, where d is very less than A. The lower triangular portion you can see here is a dielectric of dielectric constant K as shown in the figure. So this is a case of diagonal dielectric which has been placed between the plates, and it's a classical case, and we have a set formula for this. So what we need is the capacitance of this capacitor. Let's start with the solution. So we already have a formula for same for the net capacitance of such case, that would be K1 K2 A square epsilon naught divided by K1 minus K2 into distance between the plates, natural log of K1 by K2. Considering that there are two diagonal dielectrics K1 and K2 being inserted between the plates. This can also be solved taking the integral portion, that is, if you take a particular segment of this, let me show it how. So you take one segment like this, one segment like this, and you will find that in this portion it will find dC1 and this portion will be dC2. And taking the net capacitance of this elementary portion of thickness dy, we can integrate and get the value of this formula, right? Now, in this case, which is given to us, K1 would be air, so K1 would be 1 and K2 is equivalent to K. Let's put the values. So, taking K1 as 1 and K2 as K, what we get is C net is equals to K A square epsilon naught divided by 1 minus K into distance between plates D, natural log of 1 by K. This can also be rewritten as, if I just take the inverse of same, I'll get C net is equals to K A square epsilon naught. Taking inverse of this, I'll get log E K, and when I take the inverse, that is the negative sign will come and this negative will make this 1 minus K as K minus 1 into D, and this is the final formula for us, right? Let's see which is the best suited option for same. So among the options, you can see that, so answer to this question would be option 1, right? Hope you understood this one. Let's move on to our next question. Now this question belongs to the section of electromagnetism. In here, a conducting circular loop made of a thin wire has area of 3.45 into 10 to the power minus 3 meters square and resistance of 10 ohm. It is placed perpendicular to a time-dependent magnetic field varying as per the given equation. The field is uniform in space. Then we have to find the net charge flowing through this loop from 0 second to 10 milliseconds. Let's find the solution. Now you must be aware of this formula of delta Q is equals to delta phi by R, where delta phi is the final flux minus initial flux, and the formula for flux is easily given by magnetic field into area. We just have to know that what is the magnetic field at 10 milliseconds and what is the magnetic field at 0 seconds. Obviously, as per the given equation, at t equals to 0, magnetic field would be 0. At t is equals to 10 milliseconds, we want to understand what would be the magnetic field. So, omega given to us is 50 pi. Therefore, time period would be equal to 2 pi by omega, which would be equal to 40 milliseconds. Thus, you can understand that the time of 10 milliseconds is basically equals to t by 4. At this time, the magnetic field will be at peak value. So what is the peak value of magnetic field in the given equation? You can see it is 0.4 Tesla. So the value of magnetic field we wanted to know is 0.4 Tesla. Now it's very easy to solve that. Delta phi would be equal to B naught into A minus 0, which is 0.4 into 3.5 into 10 to the power minus 3. So this would be 1.4 into 10 to the power minus 3 Gauss. So this is the flux change. So delta Q would be simply equals to delta phi by R as per the formula. So it would be 1.4 into 10 to the power minus 3 divided by 10. So delta Q would be equals to 1.4 into 10 to the power minus 4 coulomb, right? Now let's see which is the best option matching to it. As per the question, none of the options are matching. That means you will get bonus for this question, right? So let's take our next question, that is question number 4.